Hey, this is Mr. Drogemeyer. Thanks for joining me again for our Algebra 1 lesson videos. Today we are working in Unit 2, Lessons 8 and 9, which talks about factoring quadratic expressions. So again, a few different vocabulary terms that we're going to be looking at. Factoring, when we talk about factoring, as it says there, we're rewriting an expression or a polynomial as an equivalent product of two or more factors. So basically we are rewriting, another way of thinking of it is we're kind of doing some division here, but we'll look at some examples and how that works with polynomials and specifically quadratic expressions, which we'll talk about here in just a moment. But so one other term I want to mention is greatest common factor. Should be familiar with that from past math classes. The GCF is the greatest factor that all terms share in common. And so we're talking about dividing here. If you're just talking about numbers, for example, the number 8, we say, has several different factors. 1 times 8 is 8. 2 times 4 is 8. Those are factors of the number 8. So when we're talking about greatest common factor, I have a few examples we're going to look at here. If I have the terms x to the 4th plus x squared, we want to know what's the greatest common factor of those two terms, or what's the greatest thing that I can divide each of those terms by. Well, they both have an x as a base, and then the exponents 4 and 2. Well, if I divide by x squared, I could divide them by x, but I could also divide them by x squared. And so x squared would be the greatest common factor. And so to get x to the 4th, I multiply x squared times x squared. To get x squared, I multiply x squared times a positive 1. So the factored form here of that expression, I factored out the greatest common factor of x squared, and that becomes x squared times x squared plus 1. Now, the nice thing here is we can also check these, our factoring, to make sure that it works by going back the other direction. Well, now if I multiply x squared times x squared plus 1, remember we talked about distributive property, x squared times x squared is x to the 4th, x squared times 1 is x squared. That gets me back to where I started with that original expression that they gave us. All right, then my next one here, x squared y plus xy squared minus xy, looking for a greatest common factor here. Well, with my x terms, I have an x squared, an x, and an x. My y terms, I have a y squared, and a y. Well, I could divide an x and a y out of each of those. That would be my greatest common factor. So x, y. And so then I'm looking at, for that first term, x, y, I would have to multiply that by x to get x squared y. That second term, I would have to multiply xy times y to get xy squared. And then that third term, negative xy, I would multiply by negative 1. And so again, if we look at distributing to check our work here, xy times x is x squared y, xy times y is xy squared, and xy times negative 1 is a negative xy. So you can always check your factoring to make sure you've got it correct. And then this last one, 6a and positive 3, what's the greatest common factor? Well, 6 and 3 are both divisible by 3. That's going to be the greatest common factor for those. I just have the variable a in the first term, so that 3 is going to be my only common factor. 3 times 2a would give me 6a, and 3 times positive 1 would give me positive 3. So the factored form would be 3 times 2a plus 1. And again, I could check that as well. All right, in particular, we want to talk about quadratic expressions and how we factor those. And a quadratic expression is a polynomial that has this form, ax squared plus bx plus c. And a, b, and c in this expression, those are your coefficients. And so you can see an example of a quadratic expression down here at the bottom, x squared plus 9x plus 18. So that's 1x squared plus 9x plus 18. So the coefficients, 1, 9, and 18, are represented by the a, b, and c in that general form that we're looking at there. All right, and so a couple of notes here. It says that all factorable quadratic expressions with a leading coefficient of 1. So when they talk about the leading coefficient, they're talking about that first term that we have, so the x squared term in each of these. If that coefficient is 1, which in these examples I have here, those are all that case, then it's going to factor into this form of two binomials that looks like this, x plus n times x plus m. And n and m are going to represent constants, positive or negative numbers. All right, and then the second note that we have here says that, so when we have this case where we have a quadratic expression with a leading coefficient of 1, then we can find those two numbers n and m in our factored form by finding two numbers that will fulfill this criteria. So n times m has to equal c. C is that constant number in the quadratic expression. N plus m has to equal b. B is the coefficient of that x term in the middle. And I think this will make some more sense as we look at examples of it. So let's do that here. So if I look at this first quadratic expression, and remember we're using the form ax squared plus bx plus c. Well, a in this one is 1. It's 1x squared. So the coefficient of that leading coefficient is 1. B is going to be that next coefficient, which is 9. And then C is going to be that last coefficient, or that constant, of 18. And so what these rules up here are telling us is that to figure out what the factored form is, these two binomials here, we need to figure out what n and m are. And to do that, we know that n times m has to equal c, which is 18. So we need two numbers that when we multiply them together, give us 18. When we add those two numbers together, n and m, they have to equal b, which is 9. So we're looking for two numbers that multiply together, give us 18. When we add them together, they equal 9. And so what we want to do is we want to find factors of c, factors of 18. So if we look at, or think about what are the factors of 18, what numbers can I multiply together to get 18? Well, 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. I could also have the negatives of these. Negative 1 times negative 18 is 18, negative 2 times negative 9, and so on. But so those are all the possibilities. I'll go ahead and write those down here as well, just so we're being completely accurate. So those are all the possible numbers that I can multiply together, whole numbers that I can multiply together and get 18. The second criteria here is that those two numbers have to add together to equal b, which is 9. So looking at these numbers, if I add them together, 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 equals 9. And so what that tells us is that those are my numbers that are going to represent n and m here. So my factored form of that quadratic expression is going to be x plus 3 times x plus 6. And so that's the factored form. We can check our work here, just like we did above, by multiplying these two binomials together. X times x is x squared. X times 6 is a positive 6x. 3 times x is a positive 3x. 3 times 6 is 18. And then we combine our like terms here in the middle. So x squared plus 9x plus 18. And notice that is what we started with up here. That was our original expression. So this is just checking our work that, yes, what we came up with for our factored form is correct. All right, so let's try that again with our second example here. In this one, and again, I'm going to identify A is 1, B is -2, the second coefficient here, and then C is -24, which is our third one here. All right, now we want to think about what are the factors of -24. Excuse me. And I'm going to write those up here. Well, I could have 1 and -24. I could have -1 and +24. I could have 2 and -12, -2 and +12. I've got 3 and -8, -3 and +8, and then 4, -6, -4, +6. Those are all of the integers, so positive or negative whole numbers, that I can multiply together. That would give me -24. The pair that I'm looking for has got to be the ones that, when I add them together, give me -2. Well, in looking at these, the only one that, if I add them together, 4 plus a -6 is going to give me -2. Those are going to be the two numbers in my binomials, in my factored form. So x plus 4, x minus 6, that is going to be my factored form. And if we wanted to check, we multiply just like we did back here, and that would confirm that when we multiply those together, we get x squared minus 2x minus 24. All right, and then our last one here, x squared minus 6x plus 10. A in this case is 1 again. All of these, our leading coefficient was 1. B is -6, the coefficient of the middle term, the x term. And then C is 10. And so to factor it, we're looking for factors of positive 10. So that's 1 and 10, or -1 and -10. It could be 2 and 5, or -2 and -5. And that's the only factors that we have for 10. And so if we look through this, we need a pair that will add up to -6. Well, 1 plus 10 is 11. -1 plus -10 is -11. 2 plus 5 is 7. -2 plus -5 is -7. And notice none of those add up to that -6 in the middle. So for this particular one, we would say that we can't factor it. It's not factorable. So, and as we move on later on in this unit, in this semester, we will see how do we deal with those particular ones where we aren't able to factor them. All right, and that's all I've got for you on this particular lesson. I appreciate you taking the time to watch, and as always, if you do have questions, please let me know. Thanks, have a great day.